The reading speed of second grade students in a large city is approximately normal with a mean of 91 words per minute and a standard deviation of 10 words per minute. What is the probability a randomly selected student in the city will read more than 95 words per minute? So this is just a regular probability question with normal distribution. So we're looking at the probability that x is greater than 95. So we're going to do normal CDF. And our lower bound here is 95. Upper bound is 1E99. The mean is 91. Standard deviation is 10. So let's calculate that there. So we're going to do second vars 2, 95, comma, 1, second, comma, will give us the E, 99, comma, 91, comma, 10, close parenthesis, enter. So we get approximately 0.3446. The next question we have a random sample of 12. So we're looking at a sampling distribution now. And we want to know what is the probability that in the random sample of 12 second grade students from the city that it results in a mean reading rate of more than 95 words per minute. So again, we have a population that's approximately normal, so we're good to go even though our sample size is less than 30. So we are looking at the probability that x bar is greater than 95. So this is normal CDF. The lower bound is 95, upper bound is 1E99. Our mean is the same as the population, which is 91. And then the mean of the sampling distribution is going to be our population, the standard deviation of the sampling distribution is going to be the population standard deviation divided by the square root of the sample size. So let's calculate that. So I'm going to just do second, enter, because it's almost the same. And then I am going to change this last one to divided by the square root of 12. So I get 0.0829. So the next one, we're now looking at a random sample of 24, and we're still looking at that same probability. So we want the probability that x bar is greater than 95. So we're going to do normal CDF. 95, 1E, 99, 91, 10, which is our population standard deviation, divided by the square root of our sample size. So I'm going to do second, enter to pull back up what I typed in, and we're going to change our 12 to 24. So we get 0.0250. So we can see there that increasing our sample size decreased our probability. So our next question, we will know what effect does increasing the sample size have on probability, and then provide an explanation for the result. So increasing the sample size decreased the probability, so we saw that. So we can eliminate B and C here. So I'm just going to kind of mark through those. And what is the case? So let's think about this. So with our sample size of 12 for versus the sample size of 24. What happened to that sigma sub x bar? So sigma sub x bar in this case was 10 over the square root of 12, and here it was 10 over the square root of 24. So in general, we take a number and we divide by a larger number. We should expect what type of result. So think about that for a second. Right? So let's actually calculate these and see what we get and see if your thought process is correct. So 10 divided by the square root of 12, which we know is smaller than the square root of 24. So this is roughly 2.8868, and 10 divided by the square root of 24, 2.0412. So when we increase the sample size, the standard error decreased. So the probability there decreases because the standard error decreases as n increases. So A is our correct answer here. So here we have a teacher instituted a new reading program at the school, and after 10 weeks in the program, it was found that the mean reading speed of a random sample of 18 second grade students was 93.3. What might you conclude based on this result? So I'm going to pick the correct answer. The kind of reading context, we want to know if the program is basically effective or not. So we're looking at the probability that x bar is greater than or equal to 93.3. And we're going to calculate the same way we've done all the greater thans or less than. So we're going to do normal CDF 93.3, 1E99, and then our mean is 91. The standard deviation, so the population one, divided by the sample size, which here is the square root of 18. So let's calculate that. So second bar is 2, 93.3, comma, 1 second E99, comma, 91, comma, 10 divided by the square root of 18, close our parenthesis, close it for normal CDF, enter. So we get approximately 0.1646. So that is larger than 5%, so we're going to conclude that it's not unusual. So answer choice A here. And that's because the probability of obtaining a result of 93.3 words per minute or more is 0.1646 there.